Good afternoon, everyone. Today I will continue on the lecture on the land survey equipment used in construction project. Today we will be discussing on equipment for supporting equipment and the modern survey equipment used. The supporting equipment usually used for surveying are tripod and leveling rods. This is a tripod. This is used as a foundation for equipment such as theodolite, water pass, total station, or GPS. The tripod will need to be arranged so that it is leveled to the ground. The next supporting equipment is a leveling rod. This is used mostly in leveling survey. In a leveling survey, a leveling rod is placed on a point where an elevation is need to be measured. The water pass will read the numbers on the leveling rod, which is captured by the water pass. Nowadays, there are lots of modern surveying equipment that is used in construction projects to ease the work. Some of the modern equipment are EDM, Electronic Distance Measuring Device, Total Station, and GPS, Global Positioning System. An EDM is very useful in measuring distance that are difficult to access or long distance. There are two types of EDM, an electro-optic system and a microwave system. In an electro-optic system, there are the EDM device itself and a reflector, whereas the microwave system, the reflector is changed into a receiver or transmitter. There are advantages and disadvantages in both electro-optic and microwave system. The advantage of electro-optical is that it is less susceptible to atmospheric condition, less expensive because it has only a single transmitter needed. However, the disadvantage is that it has a shorter range. For the microwave system, the advantages are that it can penetrate fog and rain. It has longer range and the transmitter at both ends, which allows voice communication. However, the disadvantages are that its atmospheric effects are greater, susceptible to ground-reflected signal, and more expensive because it requires two transmitters. EDM measures the time required for a light wave to send a target and reflect it back. It calculates the amount of full and partial wavelengths that reach back to the transmitter. The wavelength is known quantity since it is generated by the EDM at a specific frequency. The signal leaves the EDM at 0 degree phase, goes through a number of n full phases on its way to and from the reflector, and returns to the EDM at some angle between 0 degree and 360 degree, creating a partial wavelength. In the example earlier, it is assumed that one full wavelength is 20 feet. The last partial wavelength is read on the transmitter with the value of 82 degree, 30 minutes, 38 seconds. To calculate the last partial wave is 82 degree, 30 minutes, and 38 seconds is divided by 360 degree, which is then multiplied by one full wavelength, which is 20 feet. And you will get the length of the partial wavelength is 4.584 feet. Hence, if the total number of full wavelength is 10 plus the partial wavelength, thus the total number of the total distance of EDM, reflector EDM, is 10 multiplied by 20 feet, then plus 4.584 feet, which is 204.584 feet. However, the distance needed is only half of the distance between the EDM, reflector, and EDM. So the actual size is 204.584 feet divided by 2, which is 102.292 feet. The next modern surveying equipment is a total station. This is a digital theodolite integrated with an EDM. Its function is to measure angle, distance, coordinate, and automatically process them into drawings. The last modern surveying equipment is a global positioning system. A GPS can calculate their user's location anywhere on Earth. It uses the help of satellite for reading purposes. There are two public GPS systems, the Navstar system owned by the US and the GLONASS system owned by the Russian Federation. Well, that is all for this session. Until we meet again in the next session. Thank you.